Welcome. I'd like to thank you for dialing into this short presentation on fibre reinforcement. I'm Steve Finch. As you can probably guess from the current slide, I've spent the last 19 years working for one of the companies, or the companies listed, both innovative concrete producers and market-leading fibre brands. I'm currently working for Adfil Construction Fibres. And it's going to be one of their products that I'm going to be speaking to you about today. The Durus Easy Finish, an ecological alternative for reinforcing concrete. But before I continue, I'm going to take a few minutes just to give you a quick introduction to the three main fibre types commonly used in the UK. So we start with microsynthetic fibres. European standard EN 14889. These are characterized by their physical form, so anything below 0.3 millimeters in diameter. There's two different types, monofilament or fibrillated. The benefits of using these fibers in concrete are protection against early age or plastic shrinkage, cracking when in its plastic state. Also in its hardened state, these fibres can give protection against freeze-thaw cycles and also protection for explosive spalling in extreme heat or tunnel environments. These fibres are also used in conjunction with a steel fibre or structural fibre to often give, a comprehensive reinforcement solution. Secondly, steel fibres. This is again EN 14889, not part 1. There are five types of steel fibre: cold drawn wire, cut sheet, melt extracted, shaved cold drawn wire, and milled from blocks. The most commonly used is the cold drawn wire, ranging in lengths from 30 mil to 60 mil. And these fibres can be used to replace structural steel mesh. Thirdly, macrosynthetic fibres. Again, these are classified by their physical form, so anything above 0.3 mil in diameter. These also have a lot of similar sort of reinforcement properties as steel and can replace steel mesh. And it's these fibres that I'm going to mainly speak to you about today, or focus to you today. So 18 months ago, Adfil invested in a third-party study to measure the environmental impact of its Durus products against more commonly used reinforcement methods. This is better known as an EPD, or a environmental product declaration. This was a cradle to grave exercise and verified the total global warming potential, and this is expressed in kgs per CO2 equivalents. So global warming potential, A1 through to A3, extraction, transport and manufacturing. If you look at the CO2 calculation in the table, this doesn't seem to show a good news story against the other two methods. However, if you were to then calculate these figures into a project, it would paint a very, very different picture. So the biggest market currently in the UK is the domestic beam and block house floors. Macrofibres have been accepted by Springvale, Jablite, Rackham's, Lightcast and many more as an alternative to A142 mesh, and that's currently listed on their BBA and Kierwa certificates. So a typical beam and block floor using the traditional steel mesh fabric, generally speaking, you're looking at 80 square meters for this application at 75 mil thick, which equates to 6 cubic meters of concrete. Reinforcement method A142, this weighs in at 2.22 kgs per square meter. So times that by 20 square meters, you're looking at a total project weight of 177.6 kgs. If you were to adopt the accepted 3 kilograms of Duras product, that's per cubic meter, you're looking at a total weight or product weight of 18 kilograms. So as you can see, you do the simple calculation of 18 kilograms times by CO2, embodied CO2 value. You know, there are big savings to have. So at 65.71 kgs of embodied carbon with this traditional steel mesh against 35.1 kgs of embodied carbon against the Duras Easy Finish product, that's giving you a 47% embodied carbon saving, and that's still using a very light grade of mesh. Duras Easy Finish is also well suited to many other applications. So external paving, agricultural, mineral processing environments, marine and coastal, ports and docks, also in precast elements and obviously element toppings. The benefits of these applications are both time and cost savings, along with the benefit of knowing that the reinforcement is placed correctly. It's unlikely to be exposed and rust if exposed to sulfates. Obviously, this will then give you an extended serviceable life. Most recently, we've been asked to provide an alternative reinforcement solution for a heavily loaded slab for servicing machinery during the construction phase of HS2. The slab's required for 10 years and then is likely to be broken up and recycled. The original design for the slab is 300 mil thick with 2 layers of heavily graded mesh, both top and bottom. It's a C40 concrete and there's 360 cubic meters in total. So if you were to look at the traditional method, mesh both top and bottom, it's a B785. That weighs in at 18.4 kilograms per square meter, both top and bottom equating to 36.8 kilograms per square meter. So there's a total project requirement of 44,160 kilograms. We've proposed a design using the TR34 methodology, just using 3 kgs of Duras Easy Finish, which gives you a total Duras weight of 1,080 kilograms. Again, if you do the simple calculation of timing these by their embodied carbon values, it gives you a 16,339 kg project weight for traditional steel mesh and 2,106 for Duras Easy Finish, which, as you can see, giving you massive savings against embodied carbon at 87%. This is typical, or these are the typical kind of numbers that you're going to be looking at for, you know, multi-layered mesh solutions. Duras Easy Finish or macrosynthetic fibres can also be used in the combination slab. So here's a case study for a wind turbine based in Stirlingshire, where the client was actually having issues with compaction and bridging of aggregates. This was caused by the congestion of the reinforcement cage. Duras products were used, and it was possible to remove 39% of the steel from the design, saving both time, money, embodied carbon, and provide the solution for the for the client's original situation. I just wanted to give you this slide to give you a quick insight into the, these fibres can be used in combination. Also, the savings against embodied carbon on transportation. Again, these are listed against embodied carbon for weight against the product, and as we've already indicated, the polypropylene macro fibres are much lighter than the traditional steel mesh reinforcement. And using the same transport method, they also show massive savings of 87% against steel mesh. You could also, there is an argument to also say that this could be 100% as it formed part of the ready mix matrix and it's being delivered to site regardless. So, you know, as we've already kind of indicated, you know, massive savings to be had. With reference to recycling, like the slab for HS2, macrosynthetic products, they can be used or crushed in a traditional way. So there's no complication of material separation, and these can be used as a, you know, a standard infill material afterwards. So there's a lot of energy saving to be had there also. So just to summarise, there are proven alternatives against traditional steel mesh depending on the type of project. Use of macro fibres can save time, money, reduce health and safety risks, along with obviously reduction of embodied carbon. There's technical advice available. We can offer PI PI designs through one of our ready mix partners, and the confidence using macrosynthetic fibres is growing, you know, with each and every project in the UK. So the message, you know, Adfil, we have the products, but we need to reach out to the wider community because we can't do it on our own. So we reach out to you, the contractor, our ready mix partners, structural engineers, architects, specifiers. We need to come together and challenge the norm. And I firmly believe that if we all pull our resources together, we can meet our common goal of net zero. So as the great Charles Darwin said, it's not the strongest of the species that survives or the most intelligent. It's the one that's most adaptable to change. So thank you. Thanks for your time. Like I say, thanks for dialing in. You can also always visit our website, www.adfil.com. If you've got any queries or questions, you can also email myself, sf@adfil.com. But what we will do now for the next few minutes is open questions out to the wider audience. So if you've got any questions, then please do put your hand up or give us a shout out.
There's a couple of questions that have come in that Steve is happy to answer. So I'll post them to Steve now. So Steve, thank you for taking the questions. The first question we have is with regards to plastic fibres. A lot of environmental concern has been expressed about microplastics. How has this risk been mitigated with polyfibres?
Well, like I say, microplastics getting a lot of bad press at the minute, and like you rightly know that human behaviour is the biggest challenge of microplastics getting into the environment. With reference to fibres, they're fully encased in hardened concrete, so the likelihood of them actually getting into the environment is very minimal. The only real time that this is likely to happen is during the mixing process or when the concrete's in its plastic state. And what we've done for that, and along with a lot of other fibre suppliers, is we provide the product in pre-dosed bags, so a pulpable bag that you add to the concrete during the mixing process. You don't actually open or empty the bag, you just add the bag fully, and it's a pulpable bag, so it breaks down and then the fibres are evenly distributed, and then it becomes part of the concrete matrix. So actually any handling of loose material is minimal.
Okay, thank you for that, Steve. Stop. Question 2. On a similar sort of theme about plastics, are Adfil exploring recycled materials or fibres based on non-petroleum based technologies?
So Adfil are always looking to explore new opportunities. We have an extensive R&D department based in Belgium at our head office. Most recently in the press, there's been some news about recycled wind turbine blades being used. The industry has also been looking at plant-based materials. But again, with both of these developments, it's very challenging to achieve a consistent product. So we don't work towards a large a deviation curve. We have to provide a product that's suitable and consistent. So we are looking to improve, but like I say, there are many challenges ahead. So watch this space on that one.
Okay, thank you for that. Stop. Question 3. You mentioned, Steve, during your presentation that Adfil are able to offer a PI design service. I was wondering if you could give us a few more details on that, please.
Yeah, so a lot of fibre suppliers will offer a design service. Adfil, however, will offer a fully PI design through one of our engineering partners. This is facilitated through also our concrete partners. The designs are fully compliant to whichever code most suits the project. So, for example, if it's a ground supported, it would fully comply with TR34. And obviously, this PI cover is offered free of charge, and it's via the contractual supply chain. So through our ready mix partners.
Thank you for that, Steve. Stop. Question 4. And this one, Steve, I know is a popular question. It's often asked about microfiber concrete, and that is, what is it like to power float?
So macrofibers can be power floated. Like I say, it's often challenged because people do have issues power floating the material. However, the associated problems with power floating, it's the eagerness or the urgency to get the job finished. So if you're getting on the concrete too early before it's achieved its desired hardened state, that's when you're going to have problems. It might start pulling fibres to the surface. What we always say is, if you put a foot indentation, it's less than 2 millimeters, then it's okay to start power floating. But like I say, as you're probably fully aware, that that time will differ depending on weather, temperature changes, and obviously also cement types or concrete grades. But yes, macro fibers can be power floated, but like I say, do stay off it and don't get on it too early.
That's great, Steve. Appreciate that, and thank you for taking those questions.
Thank you.